Our next speaker is Kristian Farr, who works for Sweco. Now, I'm very interested in this because anyone that's looked at the London plan or anything else that's looking at the use of evacuation lifts, the London plan has some weasel words in there which sort of suggest that the number of evacuation lifts you need, the planning rules might suggest a minimum, but then it has something or more as determined by capacity assessment. So I imagine you're going to help illuminate this. So Kristian, over to you. Thank you.
Hi everybody, so I'm Chris from Sweco, long-time listener, first-time speaker, so please bear with me. So today we're going to be looking at an evacuation lift capacity assessment, provide a bit of a case study, high-level overlook of what we've done on a live project for a 34-storey office building in central London. The main point we probably want to get out of this is providing discussion points and sort of start feeding into the panel discussion later. So any difficult questions, save it for them. The reason we've done this is because we've undertaken an evacuation lift capacity assessment in line with the requirements in the London plan. And what we've looked at is a series of arbitrary fire flows throughout the building and looked at the phase 1 evacuation of the building throughout the height of the building to give a story. We've provided one evacuation lift per core, or per stair core in this case, as we can see in the image. Lifts in dark green, and we can see the stairs and the escape routes through there, and the corresponding times have been reported. So, the London Plan. The London Plan is a policy document which sets out the highest standards of inclusive design. And to satisfy the London Plan, buildings need to be designed and incorporated the safe and dignified emergency evacuation of all users, which is why we're talking about evacuation lifts. D5 also says that as a minimum, one lift per core or more subject to a capacity assessment should be provided. And we're going to focus on the or more subject to a capacity assessment at the moment. Now, the London Plan doesn't specifically tell you how to perform one, or what an acceptable result is, or what to do, or what it means. There are some associated guidance notes which say we should assess the likely number of occupants, the nature of occupants, the calculation methodology, and the capacity that would be provided. So moving on, codes of practice and draft code requirements. 9999 is currently the only formally issued document which sets out the definition of an evacuation. 9999 is a fire strategy document for all buildings. We've also got 9991, which is for residential buildings and sets out the requirements and refers back to 9999. So at the moment, where an evacuation lift is specified, it must be designed and installed in line with 9999. Now, 9999 only allows for operator-assisted evacuation, and we'll get into that in the next slide. But we all know that 76 is coming, hopefully soon, and that may set out other modes of evacuation, such as automatic or remote. So what is operator-assisted evacuation? So an operator is somebody who is trained to operate the lifts in the event of an evacuation, and their duties should include finding out where the fire is, how many people are waiting for the lifts, operating the lifts, and talking to people. So upon an emergency signal, the evacuation lift will recall to the designated landing. It will allow any passengers to leave, and it will stay parked until such point that somebody flicks the evacuation switch at the main protected lobby, and upon changeover, this allows the operator to drive the lift and activate the communication systems. We're driving the lift from inside the lift car. Now, this building's destination control, so we've got the hidden COP in there. And one important thing to note is the operator is assumed, in this case, to remain in the lifts at all time. So moving on to the building. So we've got a 34-storey building. All our evacuation lifts are combined passenger stroke evac lifts, so their primary functionality is passenger. We've got two 1275 kilo lifts serving the full height of the building. And we've got one additional podium lift at 750 kilos. We've put on the associated car area as well, because that'll come in useful. And we need to know how big it is in line with typical analysis, but we also need to make an adjustment slightly. So the design criteria. So we're assessing a phased evacuation as specified by the fire engineer. And phase 1 ensures that the fire floor and the floor directly above are evacuated first. And then upon completion, we will evacuate the rest of the building above the fire floors, 2 floors at a time. And then once the top of the building's evacuated, we will sequentially work down 2 floors at a time. So the quantity of people we've assessed has been provided by the fire engineer, and that's broken down into 3 main groups. It's important to note that the fire engineer has written their fire strategy at 1 person per 6 metres squared, and we have analysed the building for our general lift traffic purposes at an effective density of 1 per 12.5. The figures have been broken down into these groups, and the figures have come from the latest Department for Work and Pensions Family Resources Survey for the South East and London area. And another key assumption, it's assumed that all users who require the lift are queuing for the lift, so we've used a 5-minute delay, which we'll see in the graphs. So design criteria, well, I've just said we've got 3 main user groups, but we're showing 4 here. We've got to think about the operator, because he's in the lift at all time as well, operating the lift. So what we've done is we've taken our, say, 2.95 square metres for our 17-person lift, and we've just reduced that in Elevate by 0.21 to allow for him to be there. We've also split pro rata the amount of people queuing, and the assumption, it's a fairly big assumption, is that either people should know where they're going, or the queues for the lifts will sort of self-regulate. So that's been pro rata split on available cart area. So the results. So we're looking anywhere between sort of 5.5 minutes and 12 minutes, and that's obviously dependent on, and it's a function on the amount of people that are required to be evacuated, the corresponding available car area, and the number of trips. And here we can see we've got our graphs. We can see our nominal 5-minute delay for the lifts. So what we've done looking at our queue lengths is we've allowed the queues to build up, and then once that 5-minute hits, the lifts then start working, and we can see the queues dissipating and people being evacuated in sort of 8-9 minutes. So what do the results mean? Well, I said earlier, the London plan doesn't tell us. We don't know yet. This data, we've obviously produced a report that's then going out to various people in the industry to be reviewed and accepted in line with the planning conditions, LFB, people like that. But, I mean, this building's 2-hour rated for smoke and fire, so maybe that's acceptable to leave somebody in a burning building with an alarm going off for 2 hours. Who knows? Obviously, consideration is required for the user experience, for what's going on. We probably don't want to leave people in a burning building for 2 hours. Panic will set in, human nature will kick in, people will start doing irrational things. So it's just something to think about. But for comparison, the HTM for the design of hospitals requires all visitors to be cleared in 15 minutes. It's possibly quite a vague sentence, but at least it gives us some guidance, and there are other international documents which also set out timeframes for evacuation. So, design implications. We are designing a building. So what are the knock-on implications that we've discussed? Well, the maximum queue lengths can be extracted, and we know how many people are there, and we can assign the associated area in line with the agreed areas. But that's queuing at the protected lobby. So BS 9999 states that it is essential that the queuing space does not have any adverse effects on the means of escape for the building. So we need the queuing space, which we've got here, but we also need circulation space. And now, in most buildings these days, because we want an efficient building, well, the firefighter's lift serves into the same core, into the same protected lobby. So they're often paired. So we also need queuing space, circulation space, firefighters' access and circulation space, which has a knock-on effect on the commercial implications. So just for background, a high net internal area, which is lettable area, versus the gross internal area, gives us something called efficiency. And that ensures a high efficiency ensures that the building's worth building. So large lobby areas, such as what we require here, are classed as non-lettable space, which therefore reduces the lettable space in the building, and maybe that's pushing it into an efficiency that's not financially viable. We also need to think that additional lifts may be required to satisfy the London plan of 1 lift per core, if we knew what a core was. So that may result in higher construction costs, higher maintenance costs, and a further loss of NIA. Of course, life safety is non-negotiable. I'm not saying that, but high floor plate efficiencies drive the construction industry, and there's going to have to be a shift at some point until everybody figures out the best way to go about this, and until the clients figure out, well, actually, if I need to build this building, I need to set aside this much space for a lobby, for a lift, for a stair. So some quick discussion points. So the number of people requiring a lift for evacuation dramatically increases depending on the height of the building. So at our top floors at level 34, we'd reasonably expect up to 75% of people would require a lift, and there's some good research on that. Regarding that, now, we've not included that because it was of the impression that because the fire engineer has designed the building at 50% more occupancy than we have, then we're making allowances for that. And we're over-egging it, basically, with the figures. This report only reviews the phase 1 of the evacuation. Phase 2 is very specific, as I said, as a reminder. It's the floors sequentially up above the floors, and it's the floors sequentially down. So that's probably going to be quite difficult to analyse, and also, somebody needs to develop the methodology, or somebody needs to put a nice algorithm in an analysis software. Final point, it may not always be possible to guarantee the availability of an operator. Now, this is a prestige office block in central London. We are assuming that we will have 24-hour reception and or security, and those people working the night shifts, for instance, they should be operators. Your front of house staff for the landlord should also be trained as operators, and we can sort of guarantee that. But what happens in a residential building? We've just got a normal tower block. There's no concierge, there's no security, so how can we do that? How can we evacuate it? Now, they will probably use different strategies, different evacuations, stay put, simultaneous, things like that. But it's all things that we need to think about, all things that we need to discuss. Now, Part 76, as I said earlier, hopefully may solve some of these problems. But again, until that's released, there's probably only one person in this room that knows what's in that code. So we only have the definition in line with 9999. And just some closing points from me was doing this and undertaking this study raised a lot more questions than answers. And it is now time, as the lift industry, as designers, that we need to have these discussions, that we need to understand what we want to do before we're sent down a route that we don't think is the right way to do it. Thank you.
Chris, that was brilliant. Thank you. I'm very glad that I didn't bother putting any introductory slides together for our panel discussion later, because you framed it so well. Thank you. We have time for a question or two. Right.
Easy questions only, remember.
Yeah. So Chris has already set you some homework, Richard.
He has, and he's done a great job. Thank you very much. Do you mind if I use your slide to illustrate something? If you go back to your spatial plot. Okay, see that first one, you stop at 34 and 33. Yes. I bet when your first time round, your lift is full at, it doesn't need to stop at 33.
It is, yeah.
But it's the point I was making. You've got to know whether or not to stop. And of course, we don't know, the lift is weighing the number of people in the car, and that doesn't necessarily correspond to and the bypass is not necessarily set at exactly the right level. You can fiddle it so it works. Yeah. Well, I'm just trying to explain to you. So this is where we can do better than that. And yeah, that's interesting stuff. So that wasn't a question, that was just an observation. But you didn't want a difficult question, so I haven't provided one.
So just to build on that point, so the first two peaks on the spatial plot here, it doesn't actually, just delving deeper into the data, it doesn't actually pick up anybody in the first two peaks, and then in the third peak, it takes the last sort of one or two people, and then goes to 33 and picks up and fills the car up from there.
S is higher than it needs to be.
Okay.
Any other questions? As one, I'm going to go to the back. Sorry, Rory. And then we're overrunning, but that's my fault, isn't it? It's always my fault for overrunning. It's what I do.
Thank you very much. What's a core?
Excellent question. The London plan doesn't necessarily define it. Certainly, I can only speak from experience, and in this building, it's just assumed as an escape core, which is our escape stairs that lead to the main evacuation landing. Who knows if that's correct? Again, it's something that we probably need to discuss as an industry. Not just lifts, I think everybody needs to understand what a core is and get some of the wording tightened up.
So, quick question. Why only one lift per core?
Because we are satisfying the London plan. Now, this is again a wider discussion. Is okay, we've satisfied the London plan. We've then gone and done a capacity assessment. Is that acceptable? We're not sure yet. It hasn't got to that point. Do we need to start thinking about more evacuation lifts if somebody turns around and says, well, your evacuation capacity is not acceptable? That's when we need to start thinking about that. And I think traditionally, this was sort of the key piece that was missing. And we just did one evacuation lift per core. We don't have the data, we don't have the studies yet, because this is sort of emerging, to understand, well, actually, what is the right amount of evacuation lifts per building these days, at the moment.
Thank you. Chris, not only have you provided a brilliant introduction to the panel discussion after the coffee break, but you've rescued my sorry on time management. So thank you for that.